So let's just do a quick background on MS. As with really any condition, it's a mix between genes and environment. And there's two things that happen in MS. We know there's myelin damage because we end up figuring out, our immune systems figure out how to produce antibodies to attack myelin. There's also this separate neurodegeneration that can happen, sort of independent of the myelin damage. We know these things happen. We know a lot of the players that are involved, like cell types and chemical messengers, but we don't really know what triggers these processes at the very beginning, right? We have a lot of ideas like exposure to mercury or EBV infections, stress, many things, but we just don't know exactly. But here's what we do know. We know what is involved, such as the immune system gets dysregulated. And dysregulation, just think of it as the immune system forgets the rules, that it's not supposed to attack its own tissues. It's not supposed to attack food. It's supposed to reserve its defenses for things that are foreign, that are dangerous, that we don't want in the body. So that dysregulation just means immune system gets confused and maybe starts one day producing antibodies that attacks our own tissues. In the case of MS, it's myelin. We know there's inflammation involved, and in fact, there's inflammation in the central nervous system, which is comprised of the brain and the spinal cord. So we know inflammation happens too, and that's a result of an immune system that's kind of gone rogue. We know there's changes in cytokines that are secreted, and just think of cytokines as chemical messengers that the immune system uses to communicate. There are cytokines that turn on inflammation. There are other cytokines that turn off inflammation. And somewhere along the way, we tend to produce the ones that are more inflammatory, that keep and maintain inflammation. Then there's also oxidative stress. This is kind of a complex concept to describe, but I think it's really important and it's fascinating. So inside our bodies, there's a lot of stuff happening. And there's something called oxidative stress that has to do with the stress in the environment. And it's a result of two things. One is these molecules called reactive oxygen species. You don't really have to know what they are, other than the fact that these are dangerous molecules that are highly unstable. They bounce around and they try to damage proteins, DNA. So you've got your reactive oxygen species here that cause damage. To buffer that, you need antioxidants. I know we throw on the word antioxidants all the time, but the reason you need antioxidants is to neutralize these reactive oxygen species. If you don't have enough antioxidants, or you have a lot of reactive oxygen species, the balance is off, and that leads to stress or oxidative stress. And we know that that happens at the cellular level in MS. And finally, there's mitochondrial dysfunction, another really fancy term. All you need to know about it is that every cell in our body has 500, 1,000 or more of these mitochondria organelles. They're these tiny little units that produce energy for us. So people who experience fatigue may be having dysfunction in how these mitochondria work. So, but the mitochondria are really fascinating, and they don't just work in energy production. They also determine cell lifespan. They determine how oxidative stress goes. So all of these concepts are not separate things. They're all connected, right? The immune system going out of balance, inflammatory cytokines, too much oxidative stress, and then your mitochondria kind of falling apart. This is not all of it, but these are some of the main players. What we do know is that MS is not just genetics, but it's a combination of genetics and environment. A lot of studies report that maybe 70% of it is environment, maybe just 30% is genetics, and they work together. They're not separate components, okay?